day 29. Let's see. So I have to figure out how to actually pull collision properly. So if we have an empty canvas, we're creating a row of filled pixels all around it that are not real, just fake pixels. Now, we have this iteration somewhere here. Yeah, so I guess we're not going to be ignoring that anymore. We're not going to have this go to... Yeah, and yeah, this is what I'm doing. Okay, so I suppose I should iterate backwards. So row index minus minus, we're starting from canvas height minus 1, and we're going to minus 1. That's in the top-down pixel space. So we're starting from canvas height minus 1, which is this one, 99, and we're going to this fake pixel, which is negative 1, inclusive. And left to right. So bottom up, left to right. And so we can, this code still applies, left, bottom, that's all fine. Filled, yeah, we check if with the 3 of them are filled. Now we flipped world space, and then we need to do something which is not this. Okay, well, for each pixel, so we're starting down here, 0 and canvas height minus 1. So the first one will be 0, 99, this one. So for this pixel, we can look to the left and to the bottom, right? And really what we're looking for is a corner. So like in this case, it is a corner. So if it is a corner, then we want to kind of follow that corner. So, and the specific, well, okay, so what kind of corners can we see? So we can see this kind of corner, or this kind of corner. So we're basically either unfilled or we're filled. And since we're only looking to the left and to the bottom, left and bottom, yeah, there is no other corners that we can encounter. So it's either this or it's that. So and the difference is this pixel that we're looking at filled or not. Okay, so in general though, a corner is any pixel where its fill status is different from the other two. From the other two? Let's see. Like here, yeah, this is definitely a corner. Here, this is not a corner. This is a corner. But to detect this corner, we actually have to look above. I mean, if we're looking, I mean, we could look at all the neighbors, right? Like, we don't have to look at just the left and the bottom. We could look at all the neighbors. And maybe that's actually what we need to do, because we do need to detect all kinds of corners. So detect this corner, we need to look left and above. Detect this corner, we go left and up. This is left and right. This is right and bottom. Yeah. And if I just create the opposite of that, it's the same, right? It's this and to the left. Yeah, so we do need to look at all the neighbors, okay. So we're starting from canvas, okay, so we're going to 0. And here we're going, so we're not going into the fake, the border that I added. Okay. And we need to look at all of the neighbors, not just left, bottom. Okay, so left, okay, so pixel value left, right. So this is the pixel value, this is the left, this is the right, this is the bottom, and we also need the top, which is minus. So in this, like here, we're still top down, so it's minus, gets us to the top. Okay, so that's the pixel index. That's the pixel value. Okay, pixel index, pixel value. Whether or not those are filled, maybe we don't need like a separate one of those. Really? This we kind of do need. So we do need to flip them. And the flip is the same as it was before. Left, bottom, and of course top is of course another thing that we need. Oh wait, we already have top. Right? Left, right, bottom, top. Okay, a lot of unused values, that's fine. Left, right, pixel filled, then it's left, right, and then it's bottom, top. Left, right, bottom, top. Okay, so we check that they're filled, flip to bottom up, flip to bottom up halfway through this. Okay, now we know the coordinates of the pixel, left, right, bottom, and top. So we know all these coordinates, and we know the filled status of all the neighbors and itself. So at this point we can detect a corner. That's enough information to detect a corner. So when it comes to corners, we kind of need to know, well, we need to know if it is a corner, and then if it is a corner, we need to know what to do subsequently. So what kind of corner is it? Is it like sort of left? So this corner would be left, bottom, and this pixel is not filled. Whereas this corner would be like top, right, and this pixel is filled. And once we figure that out, we kind of need to follow, well, we need to either go right, or, well, in this case we would need to, we need to go right to find another corner, and then with those two corners, we've accounted for an edge of a polygon, like of a collision shape. Yeah, and then we just follow that all the way around until we reach this pixel that we started from, this corner that we started from. Yeah, okay. And then once we outline the collision shape, we need to move on to the next pixels. But except that we already touched all these ones. So in this case, we would have touched all these pixels. So when we move on, we don't need to be looking at this pixel, we actually need to be looking at that one. The next pixel that wasn't touched by our sort of walking around the collision shape. Except that, what happens? Like if you have this situation. It's like you walk to here, then up here, then up here, then up here. So none of these pixels would be touched. Of course, there are no corners inside there, so maybe that's actually not a problem. And if this, you kind of do need to detect that. Yeah, so I guess it just works then. I guess it just works. Okay, so those are the coordinates. So I guess the first thing to do would be to check. So given this pixel index, have we been here before? Um, pixel, I guess pixels touched pix index, well actually pixel index. Yeah, it can be pixel index, right? Because we're walking around within the canvas only. So that border isn't really relevant for us. So we could just use, well actually no, we can't use pixel index. We need to use, yeah, we need to use something else. So this would be row index times canvas width plus column index. So if we touched the pixel, then we just move on to the next one. If we haven't touched the pixel, then we do all this stuff. Okay, so only go in here when we haven't touched it. Bool, pixels, touch, arena, alec, array. Well, alec and zero array actually. Arena, bool, and how many canvas width times canvas height. Okay. So initially nothing's touched, it's zeroed. Otherwise we go in here. Bool star. Bool touched before is this. If it wasn't touched before, then go in here and set it to true. There we go. Then go through that. Okay, figure everything out that we need to figure out. I suppose at this point, we are in a position where we can figure out if it's a corner or not. So what do we need to know? We need to know if it is a corner. We need to know if it's filled. What kind of corner it is basically. Well, one. I mean, we kind of know it already. So how would you figure this out? It's like if pixel filled. Oh no, yeah, no, you do. Alright. It's pixel filled isn't the same as. How many possibilities even are there? Left, right, top, right, right, bottom. So if these are the same and this isn't the same as those two, it's like pixel filled left. Let's start with bottom. Pixel filled. So if these are the same and and they're not the same. So if these are the same as each other, but not the same as this pixel, then that's so that would be bottom left, bottom and left. So just call this corner bottom left, I guess. And then we just replace this with, let's say, top left. So top is the same as left. Well, actually, yeah, this pixel has both corners. So this corner belongs to one of the collision shapes, and this corner belongs to another one. So we kind of need to do both. Well, does it? Well, in this case, not really, but here, if we were to iterate through, we would see this corner, we would walk around this shape, and we would move on. And then we would go here, we would, well, here we wouldn't see any corners, actually, you'd only see this one. So no, it only does really accurately here. Well, in this case we would detect this corner, walk around this shape, and then move on. And then here we would see this corner again. Well, actually, no, we would see this corner first, and we would walk around this whole collision shape. So now it's a bit different. What about this situation? It's like you would see this corner, then you would walk around this shape, and that wouldn't really be a problem. So, can you ever encounter a pixel that has two corners, and it's like the first one that you encounter? I mean, the only possibility is, what if there is some weirdness going on here? So that, like, if that whole thing is filled, well, actually, what about just that? That's a corner, that's a corner. I mean, I suppose it doesn't actually matter what corner we start with too much, because if we start with this corner, we'll go down, see this corner, then go to the right, and then walk around this. Yeah, I guess it doesn't, because it doesn't really belong to two different collision shapes at the end of the day, because if there are two different collision shapes, then the corners would be detected on them individually. Okay. So bottom left, top left. And then the same thing with right. Bottom left, top left, bottom right, top right. find all these corners. So like in this case it will be bottom left, and we know that this pixel is not filled. Now if this is bottom left and this pixel is not filled, that means we need to go from this pixel, in this case it's 0, 99, or well 0, 0, because we would have flipped. Yeah, we would have flipped. Pixel bottom is canvas height, 100 minus 1, 99 minus row index, which is 99, so 0. So in this case, in world space, this would be 0, 0. And we know that it's only one kind of corner, which is bottom left. So that means we need to go to the right to find a connection point there. This is filled. This is not filled. So this would detect this corner. This is filled, so it would not detect this corner. Only this pixel detects this corner. This pixel detects this corner and this corner. It does not detect this corner because that belongs to this one. It's not filled, this is filled. So okay, how would this shake out then? I mean, I guess if is corner bottom left. Let's start there. So if we just handle this case, so if we start, this is corner bottom left, then we need to go to the right to find the next one. Strictly to the right, so across that row. Okay, I'm gonna go take a break real quick. I guess really what's happening here is, well, actually no. So this is the array of touched pixels, and then we kind of need to go into a loop, and we don't exit the loop as long as there are pixels that are untouched. Because we need to touch all of them. And then we're going to be iterating through the pixels in kind of unpredictable ways. Okay, so we go into the loop, then we go through the indices. If we haven't touched this pixel before, we go in here, and we only break the loop when all pixels have been touched. All pixels touched. False. Yeah, I suppose, I guess it's just it's one of these. All pixels touched is false. We haven't touched all of them. We're gonna be iterating. Now at the beginning of this we set all pixels touched to true, and then all pixels touched to false here. Yeah, if we find at least one that wasn't touched, we just set it to false. And there we go. So this loop will kind of break itself. When we've touched all the pixels. So we always start from the bottom left. We go until we encounter a pixel we haven't touched before. So which in this case is going to be just this first one, in the very first iteration. So we encounter this one pixel, we haven't touched it before. We determine that it's a corner. Now, if it is a corner, then depending on what kind of corner it is, we will definitely add something if it is any kind of corner. Okay, so if it is a corner, then proceed, otherwise just move on. There we go. So figure out if it's a corner. If it is a corner, then proceed. Well, just knowing that it's a corner is sufficient to know that something will go into the collision polygon. So we need all of these numbers, and once we have those numbers, go bottom up to follow world space. Now it's just a matter of which ones are the relevant ones. So in this case, the relevant number is left and bottom, because it's the bottom left corner, and this pixel is not filled. If this pixel was filled, then left and bottom would still be the relevant corner. So it doesn't actually matter if this pixel is filled or not. If we detect the bottom left corner, then we add the bottom left point. Of course, what do we do about pixels that have multiple ones with those? Like this pixel that I just... like that. Well, that has 4 corners. It has all 4 corners, so all 4 need to be added, but they need to be added in the right order. Yeah, that's why I had that iteration that started like, you know, the fake row or whatever, is to avoid this. Because if we're only detecting this corner, and then we're detecting this corner kind of separately, well, can we do that though? This corner here, and then this corner. I guess we can look at it as not iterating through the pixels necessarily, but instead iterating like through the points where a corner may or may not be found. So the 0, 99 thing, well, that's 0 and that's 99, which it will transform into 0 in world space. This point may or may not have a corner on it. And like this point may or may not have a corner on it also. Actually, does zoom it let me like draw stuff? Let's see, what does it let me do? Oh, it does. Oh yeah. Okay, so if we look at it as if we are iterating through like these x's, which may or may not have corners, then it'd probably be easier than having to consider all 4 at the same time. Of course, iteration has to be done differently then. Iteration has to be done differently. Because like on the left, so we go from 0, which is this left edge, right, to 99, but we also need to consider this right side, which is 100. So, alright. So row index is that, except that it's not really it's more of an edge, I guess, row edge index. And column index is not really column, it's column edge. Okay, so column edge goes from 0 to canvas width to 100. Row edge goes from, well, it's the same idea, like it goes from 0, which is actually, well, 0, which is 99. No, row edge, no, column edge is fine. Row edge goes from 99 up to, well, up to 0, but 0 is actually the bottom edge, right? If you want to think of it that way. Do we though? Do we want to think of it that way? Or do we just want to say, well, since we're top down initially, let's just do the same thing and just say that we're going from 0 to canvas height. Okay, so we're starting here actually, in this case. So from 0 to canvas height, inclusive, so to 100. And column edge is from 0 to canvas width. Okay, so row edge 0, we are thinking of it as this top line, I guess. I mean, if this is the bottom, I mean, this is the left, and it's 0, then this should be the top and 0. Okay, touched before. Have we touched this edge before? Well, yeah, okay, this is not... So this needs to have enough for all the edges, which means we need to pad it out. Because there is one more edge than pixel. So like for 1 pixel canvas it would be 4. Would be 2, 2, yeah. Which means that pixel's touch now has a pitch. Okay, touched before, have we touched this before? Would be pixels touched plus row edge times pixels touched pitch plus column edge. Okay, what's the pixel index? So, well, I mean, yeah, that's the question though, because now we're looking at not a pixel but an edge. Okay, so like this edge is really what we're considering. So this is 0, 0. So the relevant pixels, there is actually 4 relevant pixels. So there is no pixel index. There's 4 pixel indices that we need to think about. Okay, so this would be what? Pixel index top left would be row index would be, well, it would be row edge minus 1 top left. So it would be row edge minus 1 because this is 0, 0, but we're looking at negative 1, negative 1 times canvas pitch plus col edge minus 1. Yeah, this is the top left pixel index. Then I32 pixel index top right would be pixel index top left plus 1. Then I32 pixel index bottom left is pixel index top left plus canvas pitch, that's bottom left, and then I32 pixel index bottom right is pixel index top left, bottom left plus 1. Okay, so these are the relevant indices. Now we can look at the relevant values. U32 pixel value top left is canvas pixels pixel index top left. Yeah, okay, and now top, this is bottom left, and just replace left with right. Okay, top left, top right, bottom left, bottom right. Okay, so top left, top right, bottom left, bottom right. Yeah. So these are the values. So these are the indices, these are the values. Now given that, we know if this edge is a corner, if this cross section of a grid is a corner or not. I mean, I guess okay, that goes away. So now we need to look at pixel filled top left, pixel filled top right. Pixel filled bottom left and bottom right. Okay, so now we know if they're filled or not. Okay, is corner. Yeah, alright. So is corner is going to be determined by, well, like if we're looking at this edge, that's actually 2 corners. Now this could be two, well, could it? I mean, it's kind of still one collision shape. So except that this point will appear twice in the as you walk around it. Okay, well, maybe for now let's just not think about that case. I just put an assert in there. Assuming it's not like this, if you're looking at a cross, then if 3 of the pixels have the same value, except for the one that has a different one, then it's a corner. And that's the only case, except for this one, where the two opposite ones have the same value, and the two opposite ones do not. And of course, this case is like if you're looking at this edge, then these 3 have the same value and this one does not. So that's a corner. Okay. So that's a normal corner. I really need to make sure that that other case doesn't happen though. Three have the same, one does not. And exactly one. Out of 4 values. There are 4 values. You want to figure out which one is it. Well, I mean, there's not that many combinations. 4, in fact. So we could just write it out in the same way that we have here. So bottom left, is corner bottom left? What does that mean? That means, I guess, this. So bottom left is the one that is the odd one out. Is filled bottom left is well, no, bottom left is the odd one out. So pixel filled top left is pixel filled left is pixel filled top right and pixel filled top left is pixel filled bottom right. Yeah. It's just that. So top left equals top right, top left equals bottom right, top left equals top right, top left equals bottom right, top left does not equal bottom left. And bottom right will presumably be the same. Top left equals top right, top left equals bottom left, top left does not equal bottom right. There's this bottom right. So top left, top right, top left, bottom right, top left does not equal bottom right. Okay. Let's just replace all of this with top corner, top left. And this top left reference can become bottom left. Okay, so bottom left is top right, bottom left is, wait, bottom left is top right, bottom left is top left. Well, let's do top left, top right. Wait, no, it's not top left, it's bottom right. And bottom left is top right. So bottom left is corner top left. That means bottom left is bottom right, bottom left is top right, bottom left is not top left. Bottom left is not top right. Okay, there we go. Bottom left is bottom right, bottom left is top left. There. Bottom left is top. Okay, yeah, it's probably not the most amazing way of doing it, but I think that works. Top right. Okay, the main thing is like, okay, well, not the main one. One of the things is, are we comparing to the right thing? Top right, bottom left, bottom right. Yeah, seemingly. Now, okay, now we need to go bottom up. Okay, pixel left. Well, it's not really a pixel left situation anymore. This point, yeah, actually this point will always just have the same coordinates, depending on what the edge is. So it's not really F32 world unit. I mean, I guess we can just do a V2 cross in world units. So we don't need that. Okay, so call edge and row edge. I mean, it's canvas height -1 minus row edge, I think is what's happening there. Like that first one. So canvas height is 100. No, wait, is it just canvas height? Is it just canvas height? So canvas height is 100 and row edge goes up to 100, and we want it to be 0 in at that point. So yeah, it's just canvas height minus row edge. And the very first one, where OG is 0, canvas height is 100. Because 0 is that very bottom, so with 99, yeah. Cross in world units is just that. Hello, Cheddar. Okay, so now that we've discovered the cross, we have to go and find what it connects to. We have to go walk around that whole collision shape somehow. But so given that we haven't touched this cross before, and it's a corner, it must go into the array. It must. Yeah, so let's just put it into the array. Collision points, it's called. Collision points. R push collision points cross in world units. Alright, so let's just delete this. So right now we should only find 4 of those. They're gonna be in a, so we're gonna find this one. And then we'll just keep iterating, like the way it is now, we'll just keep iterating. Well, actually, right now, like for an empty canvas, we could just keep iterating to find this one. And then if we just keep iterating, we'll find that one. So there'll be it'll be a Z and not a square. Yeah, it's gonna be wrong. So even to handle an empty canvas case, we have to do something more interesting than just to keep iterating. So given that we found a corner, we have to tell it to iterate only to the right. Well, I mean that we're gonna do that anyway. So so this first part is actually fine, but once we get here, we have to go down. And once we get here, we need to go to the left. And once we get here, we have to go up. Okay, so it's something like, well, if it's a corner, then do this. If it's corner top left, like the first one is actually not a top left corner, it's a bottom left. Well, actually, let's just run that. Whoops. Yeah, this is not right. This is pixel filled. Okay, so the first time we find a corner, oh, whoops, that's not right. Okay, so the first one, it's not a top left, not a bottom left. It is a bottom right corner, so that seems correct actually. So it's a bottom right corner. And if it is a bottom right corner, then these deltas need to change. Yeah, okay. So row edge delta is 1, column edge delta is 1. Column edge and column edge delta. So row edge, column edge, yeah. Okay. So if it's a bottom right corner, that means well, if it's a bottom right corner and the pixel is not and the bottom right is not filled, then column edge delta is set to 1, because we need to go, actually, is it set to 1? Do we actually need to go to the, no, we need to go down. Yeah, we need to go down. So column edge delta is actually 0, and then row edge delta is actually 1. It's, oh god damn it, that's in pixels, right? Yeah. Is actually 1. Okay. Else, well, else assert, I guess, unimplemented. Else if is core, well, it's an edge, right? So yeah, we need to put an assert in there to make sure that it's only one corner. It's only one corner. So if you sum them, the sum should be exactly 1, assuming of course that the Boolean semantics work as I expect them to work. Assert is corner top left plus is corner top right plus is corner bottom left plus is corner bottom right. So if we add them all together, that should be at most 1. Okay, so now that we know we are only looking at most one corner, to do we need to handle at double corner situations? Okay. If it's the bottom right, then we go down. Else if is corner bottom left. Okay, so bottom right, bottom left would be that be this one. Actually, we go down from here. And if we see this situation, then is it... Yeah, I guess we always need to go to the right. To the left, I mean. So bottom left, and this pixel is not filled. Then call edge delta is -1, and row edge delta is 0. I mean, we are going to see all of these types of corners. This corner bottom left, so this would be what, top left, oops, top left, and this would be top right. Okay, so if it's the top left corner, top left corner, that means we need to go up. So row edge delta, this is pixel space, -1. And top right means we need to go to the right. So column edge is 1. So it's 0 in two cases, -1 and 1 in the other two cases. This is 0 in two cases, 1 and -1 in the other two cases. Okay, so this seems kind of correct. Of course, this is like... yeah, this is not gonna be working right now, but so approximately it's like this. Alright, what happens here? So, because the very first pixel is going to be the corner, so if we just step in like here, we haven't touched this before, set that to true, set that to false, these are the values, then if, there we go, it's a corner or not, it's a corner, world units it's 0, 100, which is correct, then we push it into that. Oh, I think we're just walking around the same, yeah, we're walking around the same shape, that's what's happening here. Because we're never terminating the walk around. Yeah, we need to terminate the walk around when we see a corner that we've already seen. So column edge, row edge is 1. So we're going down essentially. Then we go... Oh, well, it actually doesn't work even before that. It'll just... There we go, there's the infinite loop. So it's almost like we want to break out immediately upon finding a corner. And then go into this, like, again? Oh. So it's like, I wanna... Yeah, because we don't want to go around like this. Okay. Yeah, this is not. So we have a current point, and we have a direction to go from that current point somewhere. To describe the shape, and as soon as we reach the current point, we should terminate, because the shape has been described. Of course, first we need to find the shape to describe. Because if, like, as soon as you're done describing a shape, you need to go through and do it again. Okay, so maybe these row edges, I mean, they do need to live somewhere. But maybe not here. Is there another loop in here? It's like bool inside a shape false, and then like I mean, we're not going to be modifying them, so like a v2 first inside shape, first shape point, and then like go into some kind of loop. Go into some kind of loop where once we break out, what does breaking out of this loop mean? That we've described the shape or something, like what? Like, breaking out of this outer loop means that we've touched all the pixels. But breaking out of this loop should presumably mean that we've described the shape, but if we're not inside the shape, then we need to find what that first point is. Like, if we just move this, move all of this over, well, yeah, to that yellow. Here. Oops. So start at 0. Well, presumably not starting at 0, right? We're starting at the... Well, I mean, we do need to find what the first point is. So if we're not inside the shape, then we need to find what the first point is. If we are inside the shape, then we just need to continue. It's like, if shape. Then we need to continue iterating from the current coordinates. Like current edge x, let's try it. Current edge y yeah, except the end condition, oh my god, the end condition is different depending on and we're always going in one direction. Yeah, so the thing about one... we're always going one direction. We don't actually need two-dimensional iteration. So it's almost like we could delete two of these. Whichever two they were. Yeah, so it's more like this. Yeah, so if we're already inside the shape, then things are pretty clear. We just need to know which direction we're going, and we just go in that direction. However, if we're not already inside the shape, things are more complicated. Because we need to find that first point. Maybe just have two loops then? First loop is to find the first point. Second loop to describe the shape. Yeah, maybe that is what we want. So all of this goes away. Then this also goes away actually. Yeah. Yeah. Pixels touched, all pixels touched, inside shape false, first shape point. Yeah, there you go. I guess not inside shape, but found shape. Found corner. Found first corner. First corner. Position. Okay, yeah. So the first thing would be to find the first corner. Then it would be describe that corner. Then it would be to follow it around and then just loop over and do it again for the next shape. Row edge is 0, so we're just going to iterate through all of them. 1, 1. Yeah, okay. Found first corner false. Well, really it's just these things. is corner false, and then just information about that corner. Or maybe for this we don't actually need that. Maybe what we actually need. Found first corner false, first corner position is that. Check these things. It's a cross, no, it's just corner position, right? If is corner, so, well, I mean, really it's... Really, it's just that. If is corner, found first corner true, and then first corner position is that. Like that. I need to break out. First corner break, first corner search. Go to that location. Yeah. So, now that we've broken out of this first corner search, we need to know if we found a corner or not. If we didn't find a corner, even though we searched the whole grid, that means we break. If found well, I mean, we'll break anyway, right? Because if we didn't find the first corner, then just assert that all pixels attached. Because if all pixels attached, once we reach this point, we'll break out. Okay, so if we found the first corner, then we know where it is. And now that we know where it is, we can walk around the collision shape. So in this case, there's only one collision shape. So we should be able to just do that. So what happens here is we kind of need to do this again. Except with, well, it's something like, okay, so we have a loop, and inside the loop we have current corner position is first corner position. So inside the loop we have some current position, and we just push that. And we push that into the array. And after doing that, well, actually we push that into the array only if it's not the same. If v2 eq current corner position, well, actually, well, if current corner, well, if the current position is the same as the first position, but like the second time, bool shape, well, god damn it. It's almost like a do while instead. Do while it is not the case that current corner position, yeah, so initialize it with that, then go through the loop, there. Yeah, because as soon as those two are equal again, we want to break out. Okay, so the first thing we do is we push the current corner position into the array. Then we need to do something to figure out the next corner position. Then we need to set the current corner position to the next corner position. Next corner position. Okay, so all we gotta do is figure out what the next corner position is. Yeah. To do that, we need to figure out what kind of corner it is, though. Okay. Which is what happens here. So do I pull that out? Maybe. I mean, at this point, we might as well just pull these booleans out after all. Because really what we need to know is not whether it's top left or bottom right or whatever. We want to know next corner direction. Hello, Cheddar. We just need to know what the next corner direction is. First corner position, next corner direction. Which, yeah, I mean... Yeah, I guess this is really more of a V2I situation. Where is my V2? Here. Let's also have a V2I. So that will be V2I. Does R push? Well, R push V2 from V2I, might as well. Current corner. V2 current, well, I mean, I guess it doesn't really. Current corner position F is current corner position X, current corner position Y. There you go. So push that in, and then V2I, next corner direction. Okay, so just figure that out. Somehow. And then probably pull this out. Okay, so it's just this in is. Okay, static something. Get corner info. And get corner info is going to do this whole thing. Although, well, we kind of do want that done as well. Because corner info is just these things. Corner info. Who is corner? V2I position and V2I next direction. So presumably it will just be that. So I32 row edge, I32 column edge, I32 canvas pitch, and U32 star canvas pixels. If is corner, result. Okay, so the result is corner is true. The result position is v2I. Call edge. Yeah, well, I kinda do need to know canvas height though, so this is a texture. Canvas. Yeah, this is just that. Position, and the next thing is there. And the next thing is to figure out where the next one is coming from. Okay, so then corner info first corner is nothing. Then we go in here, we go first corner is get corner, well actually no. We go corner info is get corner info, row edge, column edge, canvas pitch in canvas, corner info, if corner info is corner, then first corner is corner info, and then we go to break first corner search. Like that. If first corner is corner, then current corner, well, I mean, I guess we can just do corner info current corner is first corner. While it is not the case that current corner position is the same, I guess that should really be v2I back. First corner position there, and current corner just becomes next corner there. Current corner position. Okay, so something like that approximately is what we want. So initialize it to the first corner and do something, then at the end of that set it to the next corner and check if it's the same as the first one. If it is the same, then break out. Assert that we haven't touched all pixels. Okay. Okay, so look, we're not actually determining the next direction. But that's this stuff, essentially. Okay, so that's already in there. so result y is that, so all the equal zeros don't need to be there. So this is the result x, and this is result y. No, that's not. Okay, this is, what is this? It is a column edge. Result x. Result next direction. Okay, so that's about right. Current corner is next corner. Okay. Break first corner search. Well, depending on what the next direction is, we kind of need to go through them again. Like, it's similar, right? It's a similar loop. Wait, do we actually need this? Like, if we found a corner, can't we just do this? So if we found a corner, if first corner is corner, that means we're continuing. Otherwise, yeah, can't we just do this instead? If first corner is already a corner, then do this, otherwise do that. Either way, add it to the, well... No, well, yeah, we kind of do need to start again. Yeah. So, like, 4... So start at the current position. Yes, it's similar, but it's slightly different. next corner. So this first point is actually current corner position y plus just step 1 over plus current corner next direction y. And row edge needs to be between. Row edge is greater or equal to 0 and it's less than or equal to this canvas height. Row edge plus equals current corner next direction y. Column edge. Okay, so column edge is current corner position x plus current corner next direction x. Column edge needs to be between this and that. Current corner next direction x. So it's something like this. Attached before is handled the same way. Except that we don't really, well, we don't really care if we touched it before or not. If, well, okay, well, I mean, we do. We do, except that, okay, so if touched before, okay, if touched before, then we need to assert that this is true, and then break out. And then go to break next corner search. Actually, it's not even that. It's like, if we touch this pixel, if we touch this edge before, the only way that could be true is if we've completely described the shape. So we assert that and then we just break out of the whole thing. Break shape walk. Hopefully we can just do that. And it could be the case, well, I mean, it could be the case that we've already touched all the pixels, but if that's true, then we're gonna see that here, because we're gonna scan through all of them. Okay. Okay, if we touched this before, assert that we've completed the shape and we can just break out. We don't need to do anything else. If we haven't touched it before, then we go in here, we set it to true, we set that to false, which it's already false because we asserted it's false. So we don't need to do that. We set it to true. Go to break next corner search. If it's a corner, then we break next corner search. And what happens here is we set the current corner to the next corner. And that's it. And then at the beginning of the loop, we push it in. Whatever the current corner is, we push it in. Okay, I don't really know what this is gonna do, other than assert somewhere. So we've asserted here, alright. So let's step through this. Okay, so we go in, so corner info should tell us that it is indeed a corner. Breakout. It is a corner. Assert that. Yeah, push that in. Next corner. Okay, so current corner. Next direction y equals 1. So go down. Oh. 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 There is a world space position. And there is a... Those are different. So the world space position is different from... Yeah, canvas height minus that. So yeah, we don't actually do this here. We do it later. Position world. There we go. So this is where the flip happens. Okay. So now I'll step through that again. Okay, so the first corner will just be, yeah, 0, 0, 1. Next direction is y, 1. So go down. Okay, row edge, column edge. Okay, what is this? Row edge 1, column edge. So we're looking at the one below. We set it to true, get corner info. It's not a corner. Move on. Whoa. Excuse me? Current corner. So row edge is 1, column edge. Oh. Oh. Oh, that's right. Yeah, this loop needs to be different. Because we only ever go in one direction, so this needs to be a single loop. This needs to be a single loop. Okay, I'm gonna go take another break. Alright. So this loop needs to be different. It needs to be something like so we initialize these. Y and X. Then we go into a loop where this happens. And well, I mean, we instead of doing it like this, we could just do it here, right? Row edge plus call edge plus. Okay, now we don't need that. Now, having done this, we can actually assert that those things are true because well, they have to be. Assert that that's true. Assert that that's true. This loop doesn't, we don't need it anymore. Okay, and at the end of this, we need to assert that current corner is corner. Current corner, wait, next corner is corner. Next corner. Because we should only get here if we found, there. We should only get here if we found the next corner. Then it's set. Okay, so it's something like this. Let's see. I guess there's some assertion failure, but that's fine. Alright, let's figure this out. Alright, so I'm going to go through. First corner is found. It is a corner, 0, 0. Next direction is y is that. Y is 1, so go down. Okay, going through here. Alright, row edge 0, column edge 0, row edge plus equals. So row edge is 1, column edge is 0. Assert those things are true. Touched before, false. We haven't touched this before, set it to true. Get corner info, it's not a corner. So next iteration. The column edge is 0, row edge is 2. Alright, so we are going down. Okay. Yeah, well, this is gonna be a while. So let's canvas size. Let's reduce it to 5 pixels. Okay. There you go. This is 5 pixel stage. Run this. Alright. Okay, now let's go. Okay, apparently this is where we assert it. Corner info false. Okay, so row edge 4, column edge 0. 1, 1, so this is 0, 1, 2, 3, 4. So 5 really is where we should see in the next one. So since row edge is 4, we are not seeing anything. Okay. Is it a corner? No. Alright. There we go. Row edge is 5. This should be a corner. Is it a corner? Yes. And next direction x is 1, so we should go to the right. So that is correct. Break next corner search. Assert that it's a corner. Set the current corner to that. Current corner position in world is 0, 0. It's true. Yes. Push it in. Next corner. What is the value stored to next corner during its initialization is never read. Actually, hold on. I think I see kind of what the problem is. So we initialize next corner to nothing. Yeah, it's not current corner position that we're really interested in. Yeah, so this is not current corner position. This is actually a v2i of column edge and row edge. This is what the assertion should be, I think. Okay, so we're still asserting somewhere there. But at least we're not asserting where we were asserting previously, so at least that one works. Okay, now, next corner equals nothing. And apparently that's a problem. But like only a little bit. That stores. Well, I mean, I'm trying to zero it over here. I mean, okay, and what if I do this? Then is that okay? And initialized. Oh no, that actually, that's fine. Okay, I see. I just leave it uninitialized. Apparently that's somehow better than zeroing it out. Yeah, I mean, whatever. So that's not that big a deal. So let's step through this again. Okay, so that is our... It's not a corner, not a corner, not a corner. We need to go all the way to row edge 5. Current corner equals next corner. Okay, so now we're going current corner is in 0, 5, next direction is x is 1. Add to watch. Row edge is 5, column edge, add to watch, 2. So again, we need to go all the way to 5. It's not a corner, this one's a corner. 5, 5. True. Yeah, next direction y is -1, so we need to go up. Push it in. So now we need to go all the way to 0. Not a corner. So this one. Is it the corner? Yes. Next direction x -1. Push it in. Now we're just gonna go back to 0. If we touched this before, assert, break shape walk. Okay. All pixels are touched. Okay, first corner. We've touched that, we've touched that, we've touched that, touched that, touched that, touched that, touched. Touched 1, 1. Okay, 1, 1 is untouched. Oh, I think, yeah, what's happening here is we haven't touched all the pixels. But there are no corners to be found. Yeah, 4, 4, 4, 5, 5, 0. All of this was touched before anyway. Okay, so first corner is corner. No. I guess this assert is, yeah, it's not really correct. Okay, so what are we pulling out? No, that's not what I wanted to do. Okay, what are we pulling out? Okay, so it looks like we have pulled out something. If it's the correct something, I don't know. Okay, well, oh god. Okay, looks like the bottom wall is the bottom wall. The left wall and the right wall are what they claim to be. And the top wall is also what it claims to be. Okay. Yeah, so that 5 pixel canvas is being pulled out correctly, right? Oh, fuck. Okay. So this works well enough. Okay, so of course we are only pulling out one shape in one stage. But this is the main this is the main part of the thing. Everything else is a lot easier than that. added all of this corner stuff. Removed like trailing white space or something, presumably. And then rewrote all of this working. That is still the case, yep, that is still the case. But we need to pull that from art. That's fine, come on. Added v to I and v to I ec. Generated. Oh my god. Okay, generated is all good. STB image, I just added this no lint because it was giving a spurious warning. Okay. I guess pull out one collision shape from art. Okay, and that's all for today. Thanks everyone.